Okay, section 7.4, the other trigonometric functions. We are going to knock off pages 4 and 5 in the notes. Pretty straightforward. So a function is even if f of negative x equals f of x for all x values of the function. So let's talk really quick about what that means. That means if I plug in the positive x right here and the negative x, positive x gives me this y, negative x gives me this y. They are the same y. So an even function, the positive value and the negative of that same value is going to give us the same output. Okay, so the positive input, negative input gives us same output. When we're talking about an odd function is odd if f of negative x equals negative f of x. Basically means when you plug in negative x, you get negative y. Okay, what that's going to look like is what we call symmetric about the origin. This is the second graph. Here's our origin. What that means is if I were to take this and flip it 180 degrees, I just flipped my iPad upside down. I know that doesn't make sense. But notice the graph looks exactly the same. I guess this is auto-adjusting, so that was not incredibly useful, but you get what I mean here. Okay? If a function is even, it's symmetric about the y-axis. We could fold this in half along the x-axis, and the left side and the right side would lie right on top of each other. If a function is odd, it's symmetric about the origin, which also means that it rotates 180 degrees about the origin. Interestingly enough, the only way that can happen is if the origin is on the graph. So we need a point kind of that we could stick a pin in and hold the function down as we rotate it 180 degrees. Okay. So if the point 3, 4 is on the graph of an even function, keep in mind with our even function, it means we can plug in the positive x, the negative x, we get the exact same y. So if we plug in positive 3, we get 4. That means if it's even, we can plug in negative 3, we're still going to get 4. Okay. If the point xy is on the graph of an even function, positive x gives us positive y. If it's an even function, negative x also gives us positive y. Next one, we've got the point negative 2, 4 on the graph of an odd function. Okay. Odd function means if I plug in negative x, I get negative y. So if negative 2, 4 is on the graph, positive 2, negative 4 is also on the graph. Okay, and the last one here, if the point positive x, positive y is on the graph of an odd function, positive x gives us positive y, then negative x gives us negative y. We also want to figure that out based on looking at the graph, okay? So here, this graph does not reflect across the y-axis. So we know this is not even. Okay. If I take a look at this, and you can do this easier on paper, if we're rotating the paper 180 degrees and just flipping it so it's upside down, our graph looks exactly the same. So we know this graph is odd. Okay. Second one here. if I were to fold this in half along the y-axis, here's my y-axis, the one side would lie right on top of the other side, so I know this is even. So yes, it is possible for a relation to be both even and odd. If it's a function though, it's not going to be both. So we will talk about that later on when we kind of look at some of the funkier functions. For now, we're just worried about even, odd, or neither. Okay, last one here. So here's our axis of symmetry. This is what splits it in half. So this reflects across the line x equals -1, but not the y-axis. Apparently I can't talk and write at the same time. So this is not even. Okay, and I can even just pick a value. This looks like it goes through 1, 4. If this were odd, -1, -4 would be on the graph, and it's not. Also, the origin's not on the graph, so this is not odd. And that's kind of what I'm going to use as my disclaimer. Origin, not on graph, not odd. So this graph is neither even nor odd.